Can a machine truly think? This question echoes through labs and lecture halls. We build tools, complex machines, some now learn, solve problems, even create. But is this thinking? Is it the same spark that ignites our own minds? We wonder if a mind like ours could ever emerge from wires and code. It's a profound inquiry, touching the very definition of ourselves. Humans have long dreamt of artificial beings. Ancient myths tell of animated statues. Legends speak of golems brought to life. This fascination is deep within us. We yearn to understand intelligence and replicate it. Artificial intelligence, or AI, is the modern pursuit of this dream. AI seeks to make computers perform tasks that usually require human intellect. From simple calculations to complex strategies, AI is expanding its reach rapidly. Could a machine one day ponder its own existence? Could it gaze at the stars and wonder, as we do? This is not just science fiction, it is a serious question for scientists and philosophers. The journey to answer it is filled with challenges and amazing discoveries. We are exploring what it means to be intelligent, pushing the boundaries of what machines can achieve. So let us embark on this exploration into the world of AI. We will look at its history, examine its current abilities, and ponder its future potential. Can a machine truly think? The answer is not simple. Join me. The idea of thinking machines is not new. It stretches far back into our past. Ancient civilizations imagined automatons, mechanical beings that could move and perform tasks. Think of Hephaestus in Greek mythology, who forged golden servants said to possess intelligence. These early dreams show our enduring fascination with creating artificial life and minds. Philosophers too have pondered these ideas. René Descartes, in the 17th century, saw animals as complex machines but believed humans were different, possessing souls and reason. This set the stage for later debates. If animals are machines, what about future machines? Could they ever achieve reason? The 19th century brought new tools. Charles Babbage designed his analytical engine, a mechanical computer. Ada Lovelace, a remarkable mathematician, saw its potential beyond mere calculation, imagining it could compose music and envisioning creative possibilities. Lovelace is often called the first computer programmer. Her vision hinted at a future where machines did more than just crunch numbers. Then came the 20th century and the dawn of electronic computers. Alan Turing was a key figure, laying theoretical foundations for computation. In 1956, a group of scientists gathered at Dartmouth College, officially coining the term artificial intelligence. They believed machines could simulate human intelligence. Their optimism was boundless. They set out to build thinking machines. A new scientific quest had truly begun. Who was Alan Turing? A brilliant mathematician, codebreaker, and visionary. During World War II, his work was crucial in cracking enemy codes. But Turing also thought deeply about machines and their potential for intelligence. He proposed a way to test this, famously known as the Turing Test or the imitation game. Imagine you are a judge in a room, communicating with two entities via text-based chat. One entity is a human, the other a machine, and you don't know which is which. Your job is to figure it out by asking any questions you want. If you cannot reliably tell the machine from the human, then the machine passes the test, exhibiting intelligent behavior equivalent to a human's. The Turing test is not about consciousness or true understanding, it's about performance. Can a machine act like a human? Can it fool us with its conversation? This was Turing's pragmatic approach to gauge progress and sidestep endless philosophical debates. If it talks like a human, perhaps it is, for all practical purposes, thinking like one, or at least simulating it very well. For decades, the Turing test has been a benchmark, inspiring AI researchers and sparking much debate. Some say it's too easy to trick, while others argue it doesn't capture true intelligence. Despite criticisms, it remains significant. It forced us to think about what makes human conversation unique. It pushed AI to develop more sophisticated language abilities. It's a simple idea with profound implications. So we ask if machines can think. But what is thinking really? Our own minds are vast, complex universes. Thinking is not just one thing, it is a symphony of processes. It involves memory, recalling past experiences, and accessing stored knowledge. This helps us make sense of the present moment and guides our future actions. Thinking involves learning, adapting, acquiring new skills, and updating our understanding of the world. This learning can be explicit, like studying a book, or implicit, like learning to ride a bicycle. Problem solving is another key part of thinking. We face challenges, analyze situations, and devise strategies to overcome obstacles. This requires logic, reason, and sometimes a leap of insight. But what about creativity and emotion? Are these part of thinking? Many would say yes. We compose music, write poetry, and invent new technologies. This creative spark seems distinctly human. Our emotions also influence our thoughts. Joy, sadness, fear, anger, these feelings shape our decisions and color our perceptions. They add depth to our inner lives. Can a machine truly experience these? So, when we ask if a machine can think, we must be specific. Which aspects of human thought are we talking about? Calculation? Yes, machines excel at that. Logical deduction? AI is getting very good. But what about intuition? That gut feeling? What about self-awareness? Understanding one's own place in the cosmos? These are the deeper, murkier waters of human cognition. The challenge for AI is immense. The question of machine thought isn't just for scientists. Philosophers have wrestled with it for ages. They explore the nature of mind and its relationship to the physical body. This is the classic mind-body problem. Are mind and body separate things? This view is called dualism. Your mind, your consciousness, is somehow distinct from your physical brain. Or is the mind simply what the brain does? This view is called materialism or physicalism. Thoughts, feelings, consciousness, these are all products of physical processes. They arise from the complex interactions of neurons in your brain. If materialism is true, then perhaps a sufficiently complex machine, made of the right stuff and organized correctly, could also produce a mind. This opens the door, theoretically, for machine thinking. Philosopher John Searle offered a famous thought experiment called the Chinese room argument. Imagine a person in a room who doesn't understand Chinese but uses a book of rules to manipulate symbols. To someone outside, it looks like the room understands Chinese, but the person inside does not. Searle argued that this is what computers do. They follow programs and manipulate symbols without truly understanding the meaning. Let's talk about consciousness. This is perhaps the deepest mystery of all. What is it? Simply put, it's your subjective awareness. It's the feeling of what it's like to be you. You see the red of an apple, feel the warmth of the sun. These are subjective experiences called qualia. The hard problem of consciousness is explaining why we have these experiences. Can a machine be conscious? Could an AI ever have subjective experiences? If a machine says, "I am happy," does it actually feel happiness? Or is it just outputting words based on its programming? Many believe that without consciousness, a machine cannot truly think in the human sense. If AI is to truly think like us, it might need to cross this mysterious threshold of consciousness. How do we even begin to build something that might think? One popular approach is inspired by nature, specifically by the human brain. Your brain is an incredible network with billions of nerve cells called neurons, interconnected to form trillions of connections called synapses. Neurons communicate with each other using electrical and chemical signals. This vast, intricate web is where your thoughts arise. Artificial neural networks, or ANNs, try to mimic this structure. They are mathematical models running on computers. An ANN consists of layers of artificial neurons, or nodes. Each node receives inputs from other nodes, performs a calculation, and sends an output to other nodes in the next layer. These connections have weights that determine the strength of the signal between nodes. How do these networks learn? They learn from data, lots and lots of data. Imagine you want an AN to recognize pictures of cats. You feed it thousands of images, some are cats, some are not. For each image, you tell the network if it's a cat. If the network gets it wrong, it adjusts its internal weights. This process is called training. Gradually, the network gets better at identifying cats. This is the essence of deep learning. Modern AI can be astonishingly good at imitation. Think about chatbots that can hold conversations that feel remarkably human-like. They can answer your questions, tell jokes, and even express what seems like empathy. AI can also create art, compose music, paint images, and write poetry. The outputs can be beautiful and surprising, but is this simulation the same as genuine understanding? When an AI chatbot says, "I understand how you feel," does it truly grasp your emotions? Or is it just selecting words based on its programming? It has learned from vast amounts of human text, knowing which words often follow other words. It excels at predicting plausible sequences. This is a powerful ability. Consider a parrot that can learn to say, "Hello, how are you?" and even say it at appropriate times. Does the parrot understand the meaning of those words? Most scientists would say no. The parrot is mimicking sounds, associating those sounds with certain situations. This is a central debate in AI. Is current AI closer to the parrot, or is it on a path to genuine comprehension? When an AI generates a new image of a cat, does it know what a cat is? Does it understand its furry nature, its hunting instincts, its place in the ecosystem? Or has it just learned the statistical patterns of pixels that usually form a cat-like shape? Current AI, even the most advanced, is often described as narrow AI. This means it excels at specific tasks. An AI can be a world champion at chess, diagnose medical conditions, or translate languages. But each AI is specialized. The chess AI cannot diagnose diseases, and the translation AI cannot play chess. They operate within their programmed domain. Humans possess general intelligence. We can learn a vast range of tasks and apply knowledge across domains. We understand context, grasp nuance, reason abstractly, and adapt to new situations. There's a vast difference between pattern recognition and true understanding. A neural network might identify a stop sign, but does it understand what a stop sign means? Does it know about traffic laws, pedestrian safety, the consequences of ignoring it? Probably not, in the human sense. It has learned that a particular configuration of pixels correlates with the label stop sign. This is not the same as comprehension. Can AI bridge this gulf? Can it move from narrow AI to AGI? This is one of the ultimate goals of AI research. The path to AGI is long, uncertain, and filled with profound challenges. So we return to our grand question, can a machine truly think? We've journeyed from ancient dreams to modern algorithms. We've explored the Turing Test, touched upon philosophy, peeked into the workings of neural networks, and pondered consciousness. We've seen the difference between mimicking thought and truly understanding. The landscape of this question is vast and ever-changing. As of today, in 2025, most scientists would say no. Machines do not truly think in the rich, multifaceted way humans do. They don't possess consciousness, lack genuine understanding and common sense. They are incredibly powerful tools, expert simulators, performing tasks that once seemed exclusive to human intellect. But the inner spark, the subjective experience, the deep comprehension, that still seems uniquely ours. For now. But the story of AI is far from over. It is a field of rapid innovation, with researchers constantly pushing boundaries. What seems impossible today might be commonplace tomorrow. Will we one day create a machine that satisfies even the staunchest skeptics? Will we build an AI that not only acts intelligent but is intelligent, perhaps even conscious? The universe is full of surprises. Our own intelligence is a product of cosmic evolution. The quest to create thinking machines teaches us invaluable lessons, expanding our horizons and challenging our place in the universe.